In this video, we're going to take a look at exam revision for graphs and transformations. Now, hopefully before watching this video, you have seen the previous videos on, for example, sketching cubics, sketching quartics, and transformations. If you haven't already watched those, be sure to check those out. You should find that it helps with this video and the exam questions within this video. Now, there is just a series of exam questions within this video. I think we've got about 5 or 6 questions in total. So what we'll do is we'll just work through these as we go. What I'd suggest here is to pause the video as we work through each question, have a go before we attempt it here, and then just check that your solution matches what we get on the screen. Okay, so let's jump into the first one here. Now, what we've been given here is this function f of x, and this is equal to x plus 2 times x squared plus 2x minus 8. Now, we're asked to sketch this curve here. Okay, so y equals f of x. Now, when we're sketching curves like this, we need to be able to identify whether this is, say, a quadratic, a cubic, a quartic, or, for example, a reciprocal graph. Now, in this case, hopefully you notice straight away that this is a cubic. If you don't notice that this is a cubic, the way to identify this would be to expand these two brackets here. Once you expand these, you get an x cubed term here, so x times x squared, we'd get x cubed. Okay, so we know we've got a cubic expression. Now, we can't sketch this straight away, and the reason why is because we've got this x squared plus 2x minus 8 here. Okay, it's causing a bit of an issue, and the reason for that is because we want this in fully factorized form. Once it's in fully factorized form, we can easily sketch it. So what we need to do here is factorize this quadratic. So factorizing this here, hopefully nice and straightforward. This would be plus 4 and x minus 2. Okay. That's our factorized form. And what we can see here then is that f of x can actually be expressed as, so we've got x plus 2 here, so x plus 2 times x plus 4 times x minus 2. Okay, so notice I've just replaced the quadratic here with its factorized form and then done the same for f of x. Okay, so now that we've got it in fully factorized form, we can easily sketch y equals f of x. The first thing we need is the roots or the solutions, so that's where it cuts through the x-axis, and we can easily identify that from the factors. Okay, so my first solution is x equals minus 2. My next solution is x equals minus 4, so x equals minus 4, and then finally x equals 2 there. Okay, so if we note those on the x-axis here, we've got minus 4, let's say that's there, minus 2, and we've got positive 2. Okay, it doesn't have to be perfect, it's just a sketch. And what we also need here is where it intersects with the y-axis, so the y-intercept here. Now, if we think about expanding these 3 factors here, what we'd get then is something of the form, so f of x would be equal to ax cubed plus bx squared plus cx plus d. Now this d here, this term at the end, this constant, this is what gives us the y-intercept. If we think about a very basic example here of a quadratic, so let's say we had y equals the general quadratic, so y equals ax squared plus bx plus c. Remember the c here just gives you the y-intercept, and it's the same here for a cubic expression. So to get d, all we need to do now is multiply 2 by 4 by minus 2. Once you expand once you multiply these numbers together, that would give you the d here at the end. Okay, so d is equal to 2 times 4 times minus 2. Okay, 2 times 4 is 8, turns up by minus 2, and we get minus 16. Okay, so we know that on the y-axis, we can put that there, minus 16. So now we just need to sketch this, but we need to understand the general shape of our cubic. And to assess that, we just need to multiply the x terms together. So x times x times x, this would just be x cubed. So it's a positive cubic. So we know the general shape will be something like this. So it's an n going into a u. Okay, something like that. So we're going to start in the bottom left down here. So we start in the bottom left. We go up through minus 4. Let's say that's minus 4 there. My sketch isn't perfect. We go up, that's our n. We come back through minus 2. We need to go through minus 16 here, and then come back up positive 2. Okay, my sketch isn't brilliant, but you can see we've got the general shape. We've got this n here going into u, and then we come back up. Okay, so that's for y equals f of x there. Okay, and that's our solution to the first example. Again, just note here though that you need to make sure it's clear where it intersects with the x-axis and the y-axis. So that's minus 2, that's minus 4, that's minus 16, and that's positive 2 there. Okay, and that's our solution to the first question. For the next one here, this one's hopefully quite a straightforward question. It's more of essentially a GCSE type question here. So what I've got is a point P, and it lies on this curve with equation y equals f of x. Now there's two parts to this. Part A, we have to state the coordinates that point P is transformed to with this equation. So y equals f of x minus 3. So what do we do here? Well, we just take a look at this new equation, and we notice the only thing that's actually happening here is we've got this x minus 3. It's in the bracket with the x, so it affects the x coordinate only. There's nothing on the outside in front of the f or added or subtracted at the end here, so the y coordinate will stay the same. So we can note that straight away. So that was minus 3, so that will stay as minus 3. But the x coordinate here, we need to consider what happens now. So like we said, this affects the x coordinate only. So the common mistake here is to subtract 3 from the x coordinate. But we don't subtract 3, we actually add 3, okay? So you do the opposite. So if this is x minus 3, we add 3. If it was x plus 3, then we would subtract 3 in that case, but because it's minus 3, like we said, we just add 3. So 3 plus 3 gives me 6 there, okay? So we get 6 minus 3 for part A. For part B, there's actually two parts to consider here. I've got the 2 in front of the f here, so let's just write this out in full. So I've got y equals 2f x plus 1. So we've got this 2 here in front of the f, so that will affect the y coordinate. And I've got this x plus 1 here again. So in the bracket again, affects the x coordinate. So if we start with the inside of the bracket here, just like we did for part A, and then remember we do the opposite. So we don't add 1 to the x coordinate, we actually subtract 1 here. So my x coordinate, so it's 3 here, we subtract 1, so that would be 2. We get 2 there for the x coordinate. For the y coordinate now, this 2 here, this tells us that we actually multiply the y coordinate by 2. So it's minus 3 times that by 2, we get minus 6. We get 2 minus 6 for part B. That gives us the solution to that question. For the next one here, it's very similar to the last one we've just done, but this time we actually need to sketch the curves. So what I've got is a quadratic, y equals x squared minus 2x plus 1. We have this minimum point here at 1, 0. And we need to now take into account these two curves. So I've got y equals f of x minus 2. So in this case, remember, this affects the x coordinate only. It's in the bracket with the x. And we do the opposite. So if it's x minus 2 here, we add 2. Okay, so my new coordinate for the minimum point, and that's all we're concerned about here. So just showing the coordinates for the minimum point. Then our new minimum point will be 1 plus 2, giving me 3. And there's nothing affecting the y coordinate. So that stays the same. Okay, so essentially this curve here is just translating 2 units to the right. Okay, so if we sketch this, we can say that's 3, 0 there. Again, it doesn't have to be perfect, it's just a sketch. So that's 3, 0. If I kind of try a quick sketch what this would look like. My sketches are never great, but it'll look something like that. Okay, so that's y equals f of x minus 2. Okay, y equals f of x minus 2. So that was for part A. We now need part B here. So that's for y equals f of a quarter of x. Now there's two ways to kind of consider what actually happens here. So like we saw before, when we had y equals 2f of x, and we multiplied the y coordinate by 2 because it was outside of the bracket of x here. Okay. Now, because it's inside the bracket, it affects the x coordinate only. There's nothing in front of the f here, sorry, or adding or subtracting at the end. So the y coordinate will stay the same. So we can know that straight away. The y coordinate stays the same, so that will be 0 again. But for the x coordinate, we've got to be slightly careful. So there's two ways of considering this. We can either divide by this value here. So if this is f of ax, we can divide by a, or we can times by the reciprocal of this. So 1 over 4, which is the same as just dividing by it. So it's completely up to you. I like to just remember it as dividing by a. So in that case, we're doing 1, the x coordinate. So let's do that down here. 1 divided by a quarter. So that's the same as 1 times by 4, which would give me 4. Okay, so we get 4, 0 there. And again, we just need to sketch this here. Doesn't have to be perfect, so just note that that's 4, 0. That's 4, 0. So if we sketch this here, again, it'll look something like that. There we go, that's our curve. So that's for y equals f of a quarter of x. So y equals f of a quarter of x. Okay, and there we have it. So that's our solution to that question. Moving on to the next question here, what we've got is the graph of y equals h of x, where h of x is 1 over x. So that's the reciprocal graph. And this is translated so that the asymptotes are at x equals -2 and y equals 0. And what we want to do is find the equation for the transformed function in the form y equals 1 over x plus a. So what I do here to begin with is just consider 1 over x. So if I sketch this, doesn't have to be perfect. We're going to get something that looks like this. Okay, that's our reciprocal graph. So that's h of x is equal to 1 over x. Okay, so it looks something like that. Okay, now we can note we have two asymptotes here. So if I do these in different colors, we've got the asymptote here along the x-axis. Now this would be y equals 0. Okay, so y equals 0. And we also have another asymptote. So if I do this, say, in orange, and that's along the y-axis. And this one would be x equals 0. Okay, so those are our two asymptotes here for the equation, or the function here, h of x. Now, what we're told is once it's translated, the asymptotes are at x equals -2 and y equals 0. So what we need to do is consider how that changes from our original function here. So y equals 0 is what we originally had, and in the new one it's also y equals 0. So that doesn't change. So that tells us nothing's affecting the y coordinates here. But what we can know is the asymptote here for x equals 0, that's translated to become x equals -2. So if I just sketch this again with a different pen colour, just so we can highlight this, what's essentially happening is it's moving 2 units to the left. So it's going to look something, say, like this. Okay, that would be x equals -2. Okay. Now that for that to be an asymptote here, then the curve must also translate 2 units to the left. Okay, so it's going to look something like that. And then same again here, this is going to move 2 units to the left. So this part here in this quadrant will move 2 units to the left. That's going to look something like that. Okay, so I know that's not particularly easy to see when we superimpose it on top of another curve like this, but hopefully you can see what we're kind of expressing here. So what we need to consider now is what do we actually do to impose this translation? So we would just say here this is something of the form. So this is y equals f of x plus 2. And this would translate the x coordinates here 2 units to the left. Okay, so everything's moved 2 units to the left, which is what that would be as a translation. But we want it in this form here. So y equals 1 over x plus a. Okay. So what do we do to the x coordinate to make everything shift 2 units to the left? Well, what we need to do here is add 2. Okay, just like we've done here. Essentially, we're just translating this now, or moving that into this form. So in that case, what we need here is y equals 1 over x plus 2 there. Okay, that would make everything shift 2 units to the left. If it was x equals 3, for example, then that would be x minus 3. Okay. If the asymptote here for y equals 0 had become, say, y equals 2, then it would be y equals 1 over x plus 2. So you can see that we just kind of take our form here and use it now in the transformed function, okay, or the equation for the transformed function. So essentially it's just using what you know here about this form and using it for the equation. Okay, so hopefully not too bad, but this is what you should get for this example, okay, or this question. That was just an example, don't worry about that, but that's what you should get here, okay. I moved on to the very last question here, definitely the trickiest question we've got so far. What I've got now is the graph of y equals x to the 4 plus bx cubed plus cx squared plus dx plus e. So there we go. And that's shown below, okay? Now b, c, d and e are all real constants. And what we can see from this quartic graph here is we have 4 roots, okay? So I've got this root here at -2, -1, 2 and 4. And there's 2 parts to this question here. Part A, we just want to find the y-coordinate of q. So that's the y-coordinate of q here, where it intersects with the y-axis. And then part B, we need to find the values of B, C, D, and E. So where do we begin? So if we start with part A here first, we're looking to find the y-coordinate of q. Now, the y-coordinate of q is when x is equal to 0. So if we can find the factors here of this quartic, then we can easily find the y-intercept by setting x equal to 0. So the factors here is just where it cuts through the x-axis. So what I'm going to get then is x plus 2. So if it's the solution is -2, that must be x plus 2. We get x plus 2. This would be x plus 1. This is a solution of 2, so that would be x minus 2. And this one here is a solution of 4, so that would be x minus 4. Okay. And I should have put the y at the front, but we'll put it at the end here. So y is equal to these 4 factors here. So these 4 factors here give us the sketch of this quartic. Okay. Now we know here by looking at this, the coefficient of x to the 4 is 1. So a in this case is equal to 1. So like I said, if we set x equal to 0 here, what I get left with is 2 times by 1 times by -2 times by -4. And that would give us the y-intercept here. So this is actually also e, by the way. So e here, remember, that's when x is equal to 0. So we'll do this all in one part. So e is equal to 2 times by 1 times by -2 times by -4. Okay. 2 times 1 is 2, times it by -2 is -4, times it by -4, that gives me positive 16. Okay. And that makes sense, right? We've got a positive y-intercept. If we got a negative solution, then we know something's gone definitely wrong because we can see from the graph that it should be positive. Okay, so the y-coordinate of q is equal to 16. Okay, so that's part A. Now we need part B. So this is where there is a lot of work for part B. So we want to find the values of B, C, D, and E. Now, if we think about our factorized form here, if we expanded all of this, then we get this form here. So essentially, all we need to do is expand these 4 brackets. Okay, so doing this by hand, the way I'm going to do it here is expand these 2 first, then I'm going to expand these 2. So what I've got then is 2 quadratic equations, and then I'm going to multiply the 2 quadratics together. So let me just multiply these 2 together first. So x plus 2 times x plus 1. That would give me x squared. What we'll do is we'll put this in a bracket. So x squared, I get x plus 2x, that would be 3x. And then finally 2 times 1 giving me plus 2. Okay, so hopefully that's nice and straightforward. I've just expanded those 2 brackets. Doing the same now for these 2 brackets here. We get an x squared again. I then get x times -4, so that's -4x, and then -2 times x, which is -2x. So -4x minus 2x is -6x. And then we've got -2 times -4, which is positive 8. Okay, so we get these 2 quadratics here. Now what I need to do here is multiply these 2 quadratics together. So the way I'm going to do that is begin with this quadratic here on the left and go term by term and multiply each term by everything in this right-hand expression here, or this right-hand quadratic. So x squared times x squared, that would give me x to the 4. X squared times -6x, that's -6x cubed. Okay. X squared times 8, that would give me plus 8x squared. Okay, so 8x squared. And what I've done there is I've done the first term, so we can take that off. We don't need to worry about that now. We then move on to the 3x, so 3x times x squared. give me 3x cubed. We've then got 3x times minus 6x, that's minus 18x squared. Minus 18x squared. And then 3x times 8, that would give me 24x. Okay, so 24x. We can take that off, we've done with the 3x. And then moving on to the 2 here, so 2 times x squared would give me 2x squared. 2 times minus 6x, that would be minus 12x. And then 2 times 8 would give me positive 16. Okay, so just run out of room here, but plus 16 at the very end. And there we go, we fully expanded it. Okay. So what we need to do now is collect like terms and just simplify. So we've got x to the 4 here. There's no other x to the 4s. It'll just be x to the 4. And that's what we'd expect, right? It's just x to the 4, so that's fine. We've got minus 6x cubed plus 3x cubed, and there is no other x cubed term, so that's going to be minus 3x cubed. So that's good. We've got 8x squared minus 18x squared. So that would be minus 10x squared. And then plus 2x squared, so it's going to be minus 8x squared. So we've done with all the x squared terms. I mean, you can cross these off as you go, so that's done. That's done, that's done, that's done, that's done, and that's done. We've got 24x minus 12x, that'll give me plus 12x. And then finally, we've got plus 16 here, okay? And there we go, we're done. So what we've got now is our fully expanded form here. And from here now, we can simply identify the values of b, c, d, and e. So notice b, c, d, and e are just the coefficients, with e being the last term here, this constant. So if we go along here, b is equal to the coefficient of x cubed, so that's minus 3. C is the coefficient of x squared, so that's minus 8. D is the coefficient of x, that's 12, positive 12. And e, finally, we do it underneath here still, it's just 16. And we worked out e in part A anyway. You can see that here, but just so we can see it again here, so e is 16. And there we have it. So that's our solution. Like you can see, quite a bit of work for part B. It's very easy to make a mistake there once we're expanding, but hopefully nothing too challenging there. Okay. So that brings us to the end of this video on graphs and transformations, or exam revision for graphs and transformations. Hope you find this video helpful. If you do spot any mistakes, hopefully there isn't any, but if you do spot a mistake, please let me know in the comments down below. And if there's anything that's unclear, like always, just leave a comment and I will try to get back to you as quick as possible. Thanks for watching.